What is a circle? Can I say that a circle is a set of all the points that are marked equidistant from a given point? Isn't it? I mean, suppose I mark a point in the screen, anywhere on the screen, and then I tell you that come and mark a point that is exactly 5 centimeter away from this point. Let's call this point O. Then you might come and first mark it over here. Say this is 5 centimeter away from O. Would this be the only point that is 5 centimeter away from O? It's not. This is one of the many points. How many points would be 5 centimeter away from O?
Infinity points.
Right, infinitely many points. So another point could be here, 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 another point could be here. Then someone can mark it here, then here and here. But if we sit down to mark each and every point that is 5 centimeter away from point O, then we are going to end up getting a circle that looks like this, right? So what is a circle? I repeat, a circle is a set of all the points marked equidistant from a given point, right? What is the given point known as? The given point is known as the center of the circle, right? And what is distance? The fixed distance known as?
Circumference.
No, it is known as the radius, right? The fixed distance that every point is maintaining from the center is known as the radius of the circle. Okay, understood? I hope you people also know what is the diameter of the circle. Diameter of a circle is the length of the longest line that can fit inside the circle. And of course, since that line will pass through the center, we can see that the diameter is going to be twice the length of the radius. Okay. Now, there's something very important need to understand about a circle. It is the fact that larger is the diameter, the larger would be the circle. Do you agree with this? That if I have a small circle versus if I have a larger circle versus if I have an even larger circle, the larger the diameter gets, the larger would be the circumference. Or in other words, the larger is the circumference of the circle, the larger would be its diameter. Now, there's nothing surprising in this. Obviously, the larger is the diameter, the size of the circle would become larger. Correct? Right? But what is interesting to note is that suppose if I have a circle with diameter d,
It
and
has
then I
the
have a circle
fixed
with
ratio.
diameter 2d, right? And then I have a circle with diameter 3d. Okay, it is noticed that as I double the length of my diameter, the length of the circumference also gets doubled. And when I triple my diameter, the length of the circumference also gets tripled. In other words, if the circumference of the first circle is c, the circumference of the second circle would be 2c, and the circumference of the third circle would be 3c, which tells us that the ratio of the circumference to the diameter of a circle, be it any circle, will always be constant. You can see c by d or 2c by d or 3c by d, the ratio is not changing.
The circumference is directly proportional to diameter.
Right, the circumference is directly proportional to the diameter. In fact, obviously between the diameter and the circumference, which is bigger, which would be bigger, longer in length? I mean, if you had to go from this point to this point, right, this is the shortest distance. So obviously even half of the circumference is going to be bigger than the diameter, right?
Yes, sir.
So obviously the entire circumference is much bigger than the diameter. But the ratio between the circumference and the
Sir,
diameter,
it is 3.14 times bigger than the diameter.
correct. The circumference is roughly 3 times bigger than the diameter. Actually, it is slightly greater than it's slightly greater than 3 times. Okay. The circumference of the diameter is not 5 times. It's slightly greater than 3 times. It's
pi times.
Yeah, pi times, exactly pi times, right? So 3 by 1 would be the ratio not really 3.1, approximately 3.1. To be more precise, it's actually around 3.14 times the diameter, right? Or if you want a fractional approximation, then if the diameter is 7 unit long, then the circumference is going to be approximately 22 centimeters long. Okay, so the ratio between the circumference and the diameter is approximately 22 by 7. In reality, it is an irrational number. The ratio is irrational, so we cannot really show it in decimal form or fractional form. But in the ratio, since it is a constant, has been assigned a symbol. What is the symbol? The symbol is a very popular one. It is pi. I hope all of you have heard of the word pi or the letter pi or the symbol pi. Pi is nothing but the ratio of the circumference and the diameter of any circle. Anywhere you pick a circle, the circumference is going to be pi times the diameter. Okay, we can say that the circumference of the circle is going to be pi times the diameter. In fact, because we know that the diameter is 2 times the radius, we can say that the circumference of the circle is pi times 2 times the radius. And this in fact gives us an expression of the circumference in terms of pi. Circumference would be 2 times pi times the radius of the circle. Okay, understood? Now, for questions, you can either use the value of pi as roughly 3.14 or roughly 22 by 7. But always remember, neither 3.14 nor 22 by 7 is the real value of pi. The real value of pi, I mean, it cannot be expressed in a rational form, right? The number pi itself is a number. It is an irrational number, okay? Whose value is between 3 and 4, very close to 3. Understood? All right. So this is the expression for the circumference of the circle. But a more important question is, what would be the area of a circle? How do we calculate the area of a circle? I mean, how to find the area of a circle, not the formula. Have I ever taught you how to find the area of a circle?
No, sir.
I haven't. Let's take a circle. And actually, there are multiple ways we can find the area of a circle. Now, a disclaimer before I start this. This is not really the best way to find the area, but this is a great way. It will make you believe that the area of a circle is what you popularly know. Okay. Anyways, what we are going to do now, we are going to divide the circle into many sectors. Now, because you've studied parts of a circle, you know what a sector is. It's like a slice of a pizza, right? So I'm going to divide the circle into many sectors like this. Now to start with, I'm dividing it into 8 slices. Okay, I'll number the slices. Now what I'm going to do is, see, of course, the area of the circle is going to be the sum of the area of each slice. Correct? Sum of the area of all the slices put together. But I'm not going to put them together in the form of a circle. Rather, I'm going to extract the slices and put them in a weird manner. I'm going to take slice number 1, lay it flat like this. But slice number 2, I'm going to point it opposite to slice number 1. I'll put it adjacent to slice number 1, only facing the other way. Slice number 3, I'll do the same. Now tell me something. Do you think that this shape that we have now formed by arranging the slices, is this familiar? Does it look like some other shape?
Looks like a parallelogram.
It looks like a parallelogram, but is it truly a parallelogram? Of course
No,
not. It's not a parallelogram because these sides are kind of bumpers. They're not even straight lines, right? If this were a parallelogram, right, then we could have found the area of the parallelogram by multiplying the base to the height. But the problem is, this is not a parallelogram. But imagine, instead of making 8 slices of the circle, what if I decided to make many slices of the circle? Many. So many slices that each slice would have negligible thickness. Very negligible thickness. So now my each slice is going to look like this. Maybe I cannot even draw it, but I'll try. And you can imagine this would be done till the very end. Okay. Now, don't you think that this arrangement is closer to being a rectangle than this one? This also started to look like a quadrilateral, but not really a quadrilateral that we can use. But this, as we've increased the number of slices, the bumpers have flattened out because I've divided the bumpers into many small bumpers. Still, I'm not using infinitely many slices. If I could divide each slice into a slice as thin as, a particle, then of course I will have infinitely many slices, right? Millions of slices. Then if I arrange them all in this strategy, then I would have a perfect rectangle. Do all of you agree with this? Correct? Now I know that the area of a rectangle is going to be length times its breadth. Now think about this. Where does the circumference of the circle go once we start arranging them in this manner? This arc goes here, this arc goes here, then this arc goes here, then this arc goes here. You can understand that the entire circumference gets distributed equally on the two sides. Now, for a circle with radius r, what is the circumference? The circumference is 2 pi r. So can you tell me what would be the length that would be arranged over here on one side of this rectangle? Half of the circumference, right? 2 pi r by 2. So this length is going to be pi r. And tell me what would be the breadth. Now look at the breadth. The breadth is nothing but one side of the slice, right? Correct? And what is the length of one side of the slice? It is r. So what is the area of the rectangle? It is length times breadth, which is pi r times r, which is pi r squared. And that is the area of a circle. Try to see if you can come up with another strategy to find the area of the circle. You'll get the same result, but can you use a different strategy? And let me know in the next class.